Hey guys, I'm going to talk in this video about percent composition, and hopefully the notes and examples that I'm going to go through will help you complete the assignment percent composition honors. So first of all, what we're talking about when we're doing percent composition is it's how much of a compound's mass comes from the individual elements. Okay, so a really great example is with H2O. Okay, so what this means is that for every 2 hydrogen atoms in this compound, I will have 1 oxygen atom. Okay, and even more than that, it means that for every 2 moles of hydrogen in this compound, I will have 1 mole of oxygen. Okay, now the important thing is that this does not mean that for every 2 grams of hydrogen, I will have 1 gram of oxygen. Okay, and that is because, the elements, because oxygen is so much bigger, it's not proportional. Okay, so in order to figure out like your weight comparisons, we have to do a little bit of math. Okay, so the way that we figure out the percent composition, how much of the mass comes from an individual element, is you basically have to take the total weight or the total mass of this thing and then say, okay, how much of that mass belongs to the hydrogen? How much of that mass belongs to the oxygen? Okay, so let's do the percent composition of hydrogen in 1 mole of H2O. Okay, so the way that we're going to do that is we're going to take the mass of the hydrogens and we're going to divide that by the total mass. And then because we want a percent, we're going to multiply it by 100. And that's going to give us our percentage. So how much of this hydrogen molecule, how much of the mass belongs to the hydrogen? Okay, so let's go ahead and just start plugging in some numbers here. All right, so I've got the mass of a single hydrogen, which is 1.01, and I have 2 of them. So I'm going to multiply that by 2, and I'm going to divide that by my total mass, which in this case is 2 hydrogens plus 1 oxygen. Okay, now when I plug that into my calculator, this bottom part equals 18.02, and this top part is 2.02, and plugging that in, I'm going to get, let me double check myself real quick. So I've got 2.02 over 18.02 gives me that number. And I'm going to multiply that by 100 because I want it to be a percent. So I've got 11.21%. Okay, so that is how much of the weight or of the mass belongs to hydrogen. Okay, so now let's find how much of the mass belongs to oxygen. So our percent oxygen. We're going to take the mass of the oxygen and divide that by our total mass. Okay, this one's easier. So I know that the mass of an oxygen is 16, and I know that my total mass is 18.02. Okay, so I'm just going to take 16 divided by 18.02, and that gives me this number. I multiply that by 100 to make it a percentage, and that gives me 88.79% oxygen. Okay, now just to double check myself, I'm going to add these back together because they should equal 100. And they do. So, in any given sample of water, 11.21% of the mass will belong to the hydrogens, and 88.79% of the mass will belong to the oxygens. Okay? So, let's do one that's a little more complicated. So, let's find the percent composition for all of the elements in this compound. Okay, so I have this big compound here, and I want to figure out how much each individual element contributes to the mass. Okay, so I've got N, I've got H, I've got C, and I've got O. Okay, so let's find how much that nitrogen, how much its mass is. Okay, so I know that 1 nitrogen is 14 or 16? 14.01. Okay, and I know that I have 2 of them, So that means that my nitrogen's mass is 28.02. Okay? My hydrogens, I have 8 of them, so that is going to be 8.08. My carbons, I just have the 1, so 12.01. And then my oxygens, I have 3, so 16 times 3 is 48. Okay? So let's find my total mass. So I've got 28.02 plus 8.08 plus 12.01 plus 48. That gives me 96.11. And when you're doing these, sig figs are important. Like, we're using 3 here because our original 1.01 only has 3 sig figs. And then 2 here because our original only has 2. But you can be a little bit looser with the sig figs here because we're looking at percentages. So it should all shuffle out in the end. So this is our total mass, okay? Now, I know that to find my percentage, I'm going to take my individual, so if I'm looking for nitrogens, I'm going to take my individual mass, I'm going to divide that by my total, and I'm going to multiply that by 100 to get my percentage. So I've got 28.02 over 96.11 times 100 gives me 29 let's just use 4 digits because that's always a good number to use. So 29.15%. Okay. And then I've got my hydrogen here, which is 8.08 over 96.11 times 100 gives me 8.4, let's do 407%. Okay. And then I've got 12.01 for carbon divided by 96.11 times 100 gives me 12 point oofa. So 496, that 6 would round, so 12.50. And then I've got 48 over 96.11 times 100 is 49.94. Okay? And again, these are all percentages, and we're going to add them together just to make sure. So 29.15, 8.407, 12.5, and 49.94. Okay, what did I do? 8.4, oops. Okay, so my answer is 99.997. As long as you get within, like, 99.5 to 100.5, you're pretty good. So I'm going to go ahead and call this one because that is within our parameters. So there is our percent composition. So what this means is that if I have a sample of this right here, 29.15% will be nitrogen, 8.407% will be hydrogen, 12.5 will be carbon, and roughly 50 will be oxygen. Okay, so that is how you solve a percent composition problem. Please let us know if you have any questions, and hopefully that gets you through some of these problems. Bye, guys.